Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Initially or not. But they've been working on model-driven development for a very long time. And the work that they're going to talk about today is a synthesis of things that I have learned over 10 years. 10 years. 10 years. 10 years. Yeah, welcome.
Thank you, Steve. It's really a privilege to be here, and now that we see there is some interest in modeling and model-driven development in at Microsoft also, probably we would see some heated interactions, some of the ideas which we have over here.
You should maybe raise your mic a little bit, and then speak a little bit louder.
Okay. Am I audible now?
I don't think the mic's on. I think it's on, but it's really quiet. Maybe it's not on.
He told me that it's on. It's on.
Okay.
But he said it's muted. I don't know what. If you need.
That's better.
Better? Okay. So, I would like to give you a brief introduction to what TRDDC is all about. It is essentially an applied research division of Tata Consultancy Services, which is India's largest IT organization. The center was founded in 1981 in Pune, and the mandate for TRDDC is applied research. So, we are expected to adapt and apply the latest and the best in computer science to ease the burden of IT professional, add value to the TCS offerings, and also improve the quality of software development processes at TCS. So, our endeavor had been to replace informal and ad hoc methods with more scientific techniques and more scientific processes, wherein one could be sure of certain desirable qualities being imparted to the product as well as to the process. So, the ongoing research at TRDDC is can be broadly classified as pertaining to these four major areas. One is the area of model-driven development, of which a part of it we would be presenting over here. Another is requirements modeling. How can we capture the software requirements in a formal manner? How can we analyze, validate, verify using model checking and theorem proving techniques way at the beginning of a software development lifecycle so as to identify the problems early on. Software testing, how can the testing process be automated? Can we generate test cases and test data from the specifications? Can we generate optimal test data? And how can we automate the software development process? And there is a group which is fairly active in general in algorithms of various kinds. But this talk over here will concern, we would be presenting our work in model driven development, which began in 1994 and has now culminated in a product, or can be called as an asset based offering called MasterCraft, which TCS has used extensively in a variety of its software development engagements, and about 60 to about 70 plus large enterprise class applications are active worldwide today. And when we say large, these are about 150 years, person years plus efforts, ranging from 5 to 6 million plus lines of C++ and or Java code. Okay, so this is this would be the outline of the talk which we would be following. I will begin with giving you some background on modeling and model driven development. Then we will talk about our model driven development approach, which is supported through MasterCraft. Uh, then we will discuss what were the benefits and the pain points in this approach. Then we will like to give you not exactly a demo of MasterCraft, but a flavor of what MasterCraft is, because demonstration of MasterCraft itself may take considerable time. Then we would present how we used the separation of concerns techniques to address the problem of customization of a toolset. That's MasterCraft itself. What are the observed benefits and the problem areas in using these techniques? Then we would like to give you a demo of the restructured MasterCraft. And if time permitting, we will talk about a lightweight model driven development approach, which seems to be better suited for 3 to 6 months duration projects, because TCS being a IT organization, it seems to get many projects which fall under this category, and that was MasterCraft was uh, MasterCraft seems like a too big a tool to address such projects. So we have come up with a new approach, metadata driven aspect oriented software development approach to address these problems. If we have time permitting, we would just go into the details of that and a demo of a tool set which supports that new approach. And we would like to conclude with sharing with you our vision of how product families can be supported using model driven development. And then we could just have a discussion. Please feel free to ask questions at any time you feel. Okay, so just as a background, enterprise applications are characterized by the fact that they are business critical. They tend to have a long life, like some of the systems which we had developed for a large insurance corporation in USA. That system was developed about four years ago, and they came to us saying that this system will be alive for next 20 years at least. So please share with us what is your roadmap for this technology for the next 20 years. Just to give you an idea of that is the kind of shelf life these systems tend to have. Since the systems are business critical, they expect a high performance from the underlying IT systems. Typically, they involve multitude of technologies. Minimally, the presentation manager, the programming languages, relational database, the various middlewares connecting the two, so on and so forth. Because these systems have a long life, they are expected to cope with the technology changes, because technology is changing with an ever increasing rate, and these systems are seldom islands, so they need to talk to other systems. And most of these systems, all of these systems have a very pertinent need to be responsive to the changes that may happen in the way business is run, changes that may happen in the way their organizational processes would change over a period of time, and of course the underlying technologies which are used to support these systems, those technologies itself undergo a change, opening up new business opportunities which the businesses would like to avail of. And the characteristics of the to support the development of such enterprise systems, because of the large size, one needs to have a good handle over modularization. One needs to cater to the integration right in the beginning, and because the systems tend to have, because these are large systems being developed, typically you will have large teams working on these software development exercises, and it calls for a need for coordinated development of these teams, which could be working on related parts of the system in an independent manner. Such a development exercise calls for a team with diverse skills ranging from the domain knowledge, various technologies which are being used to implement the system, and various kinds of architectures onto which these systems conform. Also, the implementation needs to conform to some standards, coding standards which could be specific to a which could vary from an organization to organization, or architectural standards. And there is need to, in order to support independent parallel development of these systems, one needs to have a separation of concerns right from the specifications all the way down to the implementation. So the current practice of, there are two major ways by which such systems get developed in industry today. One is handcrafting a solution, wherein the domain experts would define the functional requirements, architects would define a solution architecture, they would come up with the best practices and guidelines and hand over these things to the developers, who would then hand code the functional requirements into the solution architecture using primitives offered by the platforms such as general purpose programming languages, relational databases, presentation managers, middleware platforms, so on and so forth. The verification and validation that the implementation actually pertains to these best practice guidelines and the design strategies is left to the review and testing process only. Other approach is a framework based solution, wherein there are domain specific frameworks like SAP, CBEL, which package certain functionality and the way that functionality is realized. So functionality and a solution architecture is packaged and is made available to the developer, and the developer then would then customize that packaged offering or a framework using some higher level languages, for example ABAP language for SAP. And other way would be to use technology frameworks like Log4j, Hibernate, etc., which address a very niche need, and then developer makes use of these frameworks more like object-oriented class libraries, wherein you could either invoke these methods, or you could extend the classes, override them, so on and so forth. So before we present our approach, I would just like to touch very briefly on some history about why an organization which is essentially an IT consultancy organization ever thought of building something like that. In 1993, Tata Consultancy Services decided to have a asset-based offering for the banking industry in Europe, and for that it was decided that the product would be offered on a complex platform. C++ was still the de facto programming language at that point of time. Power Builder would be the presentation manager, and we would be using Tuxedo as an online transaction processing monitor. Object orientation was quite new, and object modeling tool was probably the only tool available to do some sort of an object modeling at that point of time. And the general implementation architecture for the product was, you would be having GUI in Power Builder on Windows, you would be having your data manager sitting on Oracle or PLSQL of Unix, and Tuxedo would be the transaction processing monitor connecting the two, and your business logic would be in Unix and C++. And the situation on the ground was, it was a new team, the schedules were tight, and what we had was domain experts which knew banking well. We had design experts who knew how such systems need to be architected, but we had coders who were quite new to object orientation, they were quite new to C++, and C++ is quite a difficult language to program in. So one of the major problem was how do we gap, how do we how do we reduce this gap of functionality and technology, especially when object orientation itself was an evolving method at that point of time. So we came up, so our solution was to, to define or come up with application generators which would generate an entire application conforming to all the layers of the solution architecture. We would be hiding the technological details from the developers. The design decisions would get encoded into the code generator so that architecturally consistent end-to-end application would get generated. We thought of, we came up with higher level languages which were closer to the problem domain with an objective to reduce the functional and technology gap, and it would simplify the change management by offering a higher level of abstraction. So our solution consisted of use of models to capture the structural part of an application and certain domain specific languages which would refer to the models as in some sort a symbol table, and a code generator which would take these two things as input and generate an implementation into the standard client server architecture having graphical user interface, business logic and DM as three separate layers. These layers talking to each other through some middleware of choice. Yes?
If you're talking about generation of applications, so you don't need any coders anymore, you generate everything? Or?
No, we do need coders, but now these programmers code in the domain specific languages. They don't code in general purpose programming language.
So you really generate a fully functional application
yes.
on your set of languages?
Absolutely. The application which is generated doesn't have to be touched by a developer. Yes?
Two comments. The first is that personally I find this fascinating because I feel like the slides are almost coming directly out of a book that we published in September. And no doubt you haven't seen it yet, but I just want to recommend it to you. It's called Software Factories.
Yeah,
it's essentially this.
Yeah.
And the second thing I wanted to say is that here at Microsoft, we've been using the word DSL to refer to a particular type of model.
Yes.
Although in practice we recognize, especially through the work of JetBrains and folks like that, that there's an approach called language-oriented programming, which we use domain-specific textual languages. And in the book, we actually allow for both.
Yes.
But colloquially here, the term DSL would be model. So just as a FYI, in this audience, if you put DSLs and models as different boxes, the question's going to come up, why are they different?
Yes, I'm aware of your Software Factories project and also the book which you have come up with. So yes, you use the term DSLs essentially to mean different kinds of meta models from which you would like to generate code. I was quite skeptical about how our use of models and modeling would be taken over here since the DSL thing. So by DSLs, we actually mean domain specific, textual domain specific languages in this case. Yeah.
So could you say a little bit about how the models are used by the code generator?
Okay. How the models are used? Okay.
Yeah. What do they accomplish? The models. How do they? Can you give an example of how it works?
Okay. Can we pause this question because there would be, it would get addressed somewhere down the line. And we built our solution on a meta modeling approach so that the solution itself is extensible. So these models are not fixed models. You could define any specific model which is most intuitive, most convenient to represent a problem domain, and the model-based code generators essentially are interpreters of that meta model into some code. So, a very generic or an abstract answer to your question would be code generators essentially are model to text transformers. Okay, so here is a high level overview of what our approach is. So, and we illustrate this approach using, yes.
Sorry, I don't want to belabor the point, but I didn't quite understand what your point of skepticism was. And I just wanted to be sure I got that in looking at the rest of the presentation. You said you were skeptical about, and I didn't quite get what you said.
No, when you actually remove the skepticism by defining how you what you call as domain-specific languages are essentially metamodels.
So you were skeptical that Microsoft would receive the concept well, but having seen what we're doing, you're less skeptical. Is that what you mean?
Okay, maybe skeptical is too strong a word. What I wanted to say was that I didn't want any confusion to be created by use of terminology which might mean different things. But once you clarified it, we actually use the terminology in a consistent manner. We are using these terms in a consistent manner. So now there is no confusion, and hence, and I never was skeptical about anything to begin with.
Good answer.
So I guess we do let him out alive.
Okay, so we illustrate our approach using an example of a classical client-server architecture, which conforms to the three architectural layers: the GUI layer, then application layer, and the DB layer. So the idea is you decompose your application specifications in terms of these three models: a model for the GUI layer, application layer, and the database layer. Now, these models themselves are instances of specific metamodels. A metamodel for a GUI layer, app layer, and a DB layer. And these three metamodels are essentially views of a unified metamodel. And we have model to code transformation, model to code transformers, which would translate these models independently into a code for a GUI layer, app layer, and DB layer. These model to code transformers would know, they would bring in the platform specificity. Am I generating ASP, JSP, bin forms, web forms? Am I generating C#, C++, Java, or generating for JDBC, ODBC, ProC, and on which particular database? Those decisions would get encoded into model to code transformers. And these code fragments would then be composed to get an integrated, consistent application implementation. Now, the issue over here is how do we guarantee that these code fragments which are generated independently will actually integrate well, because these models are not completely isolated. There is an overlap in between, and that overlap is made use of to guarantee consistency between these code fragments. And we are able to state those consistency requirements because these metamodels are not independent metamodels, but they are views over a unified metamodel, and hence consistency relationships that must exist between these two models so that the generated implementation is architecturally consistent can be stated in a declarative manner. We'll come to an example of this later. So, for example, this is an application layer metamodel, or it can be seen as a DSL. So, here we say that application layer consists of many classes. Classes have methods, attributes have data types. Classes can be related to other classes through some associations having cardinality properties. there is a business process. Business process can be seen as a sequence of tasks. And this is a very simplistic business process, by the way. Not as complex as what something like BPL for WS, etc. would support. A very simplistic business process. And a task is realized by a method which is implemented or offered by a particular class. The user interface layer meta model would be the things in blue conform to the user interface layer meta model, things in black conform to the application layer meta model, and so your user interface is a set of windows. Windows essentially comprise of user interface classes which talk about just the presentation aspects, and buttons. A click of a button may open another window, or a click of a button would invoke some service at the back end. The user interface classes are sets of, they have user interface attributes. Now these user interface attributes are the controls which are essentially being used to display data, to display application data. So these associations, the calls and the maps to associations, actually span the two meta models, the GUI meta model and the application meta model. We could even have a meta model for defining application-wide GUI standards. For example, you may say that a particular data type will always be represented by a particular control. Like date will always be represented by a calendar control, and then any attribute which is of type date, when it gets rendered onto the GUI, it will get rendered using this calendar control. So those things can be such decisions, standardization decisions can be taken at an application level, and the tool will ensure that the generated application will conform to such standards. This is the database layer meta model for generating primary key based standard methods like get, create, add, modify, delete, and exist kind of method. So over here, classes need to be mapped onto the tables. So you have table which has columns and a key. Key is composed of columns. Association is realized through some key, and an attribute of a persistent class maps onto a column. For non-standard database accesses, we have a query meta model, which can be seen as a query. It takes parameters which are of type class. The query returns a class, and query has a body which is specified using an extended SQL syntax. So in some sense, query is, we are providing query as an object-oriented abstraction. Now from your Q++ or a domain-specific, textual domain-specific language, you would be instantiating, you would be creating an instance of a query and then invoking this body as if it's a method onto that query, which will then return you the class which you wanted. So the handshake between Q++, which is our textual domain-specific language for specifying the business logic, and the query is object-oriented. You just instantiate a query and start invoking methods on it, which are nothing but these. So just a simple example. Get customer list is a query which takes bank as which takes a parameter of type bank, and it returns you okay, sorry, it should be multi-row. It's basically an array or a vector of customers, and the syntax is something like this: select name from customer where bank ID equal to :1.id. Now this :1 would bind to this parameter, and here it is presupposed that bank has an attribute called ID, which is the primary key of bank, and bank ID is the foreign key in a custom material. So now we'll just take a look at some of these intermodal consistency checks.
Quick question about the previous one. Just want to make sure I understand what you said. You're basically saying that you are wrapping effectively a SQL query and turning it into something that looks like a functional or object-oriented interface.
Yes.
Which has exactly the same meaning, but it can then be composed with other object-oriented stuff.
Yes. Yes. And another thing which I mentioned is, which I forgot to mention is, there are queries of different kinds. In the sense that you would like to execute the same SQL statement, but you would like a different behavior. Like you want it to be executed now in one case as a cursor, or in one case as get me all the records in just one big vector, and I would like to process that vector at my leisure, so that whole memory, all those objects would be loaded in memory. So those kinds of classifications also you can, those different kinds of behaviors you can get by tagging a query appropriately. So there are queries of different kinds.
And then you can presumably generate an iterator versus
yes.
a row set.
Yes, actually we don't generate an iterator. The query would make those, the query would offer those methods like open, close, if it is a cursor kind of a query, and the Q++ would make use of these methods. Or those iterators would come from Q++. They are not in this world. Okay, so the UI should allow the specification of all tasks in a business process and be consistent with the preceding relationship between tasks. So such rules can be stated.
So I have a general question about your notion of models and domain-specific languages. For me, a model would usually be an abstraction of the actual application, which hides away some details. What you are showing here seems to me more like high-level programming languages, domain-specific or not domain-specific, which somehow interact to actually realize the application in full detail. So why are you calling this modeling at all, to formulate it more cooperative?
Okay. We do not use the term model so as to mean an abstraction of a system. I mean, typically in mathematics, when you use the term model, it is used in that sense. But over here, it is an abstraction, but in a sense that it doesn't contain all the details. We use the term model to mean representation of a system, but not containing all the details. For example, when you talk of a business, enterprise class business system, that system typically has the following major dimensions of concerns, so to say. The application functionality, the business process onto which that application functionality conforms to, the technology platform using which that functionality is realized as a system, the various design decisions which someone has taken so that the resulting system has the desired engineering properties, and the architecture, the various kinds of distributed architecture, which specific implementation architecture you are talking of. When you talk of an enterprise class business system, you actually mean all these 5 put together, or that's how we are defining it. Now the models which we talked of over here, they are complete only as far as the functionality aspect is concerned. The rest of the information is hidden away. The rest of the information is codified as additional properties or in terms of these meta models, which then the model-based code generators would then interpret that functionality in the light of these additional properties which are there, and will generate the code accordingly. So that's the intuition.
But you would also not mind if I could call your approach actually a very high-level programming approach, or would you object if it would be called?
Actually, programming would mean that one has to cater to both the what and the how aspects. Whereas in our approach, the focus I would like to believe is more on the what and not necessarily on the how. The how part is in some sense hidden or encoded in the code generators.
So I was just wondering, is it fair then to say that the separation of concerns in some sense is a key thing that you're doing in that sense, basically that you can model one concern or you can encode or program or whatever you want to call it, one concern in isolation from all the others, and then they get composed at some lower level
Yes.
in a consistent fashion. And it's easier said than done, obviously. And so that's what you're demonstrating.
Yes. Yes, actually you have gone ahead in our presentation. I mean, the intuition, the intuition was that, but the realization, I mean, even though the intuition was of a separation of concerns, but the realization was not as elegant and as what it should have been in the first implementation of the MasterCraft. But in the second implementation, that's what we did. We'll come to that. Okay. So this is just a pictorial representation of how what one does. So you have an application, kind of a bank. A user has many accounts. So user has name, account has account number and balance as its attribute, and account supports withdraw and deposit as its methods. And on the database side, you have two tables: a table for a user, a table for an account. The fact that user and account have a relationship, have an association called has, gets realized in terms of primary key and foreign key relationship in the database tables. On the screen, you are displaying the name, the account number, and the amount, and there are two buttons, withdraw and deposit. So the button deposit is linked with, gets mapped onto the method, method deposit. The name is getting displayed over here. Same is the case with account number and the amount which the user has asked for.
Question. If you have a large number of things in the database, users, accounts, whatever, would they also be constructed in, or is that just at a model level, an implementation level? You don't necessarily have a corresponding object in the application at all times.
Okay. Typically, business applications, since they need transactional behavior, all the objects which are required, the objects pertaining to, the objects tend to have a lifetime as that of the lifetime of that particular transaction. So objects would come up and go down as soon as the transaction is either committed or rolled back. So it's not that the entire relational database is always up in memory. That would never be. So this is a realization. We would like to present a realization of our approach through a MasterCraft toolset. So the things in light green are the specifications. So the user creates UML plus model. They are the extended UML models. Writes the business logic in query, writes the non-standard database accesses using SQL, and there are set of code generators which would then translate these specifications onto the various architectural layer codes. Appropriate interfaces between these architectural layers also get generated along with some runtime library, and this entire thing can then be compiled, linked, and deployed onto any platform as of now. Yes?
So let me make sure I get this right. The assumption here is that by raising the level of abstraction, the user can program, less skilled users can program fairly sophisticated applications and in a shorter amount of time and generate stuff. My question is, what happens when something doesn't work? Which is, you generate this stuff and it's somewhere down the line there is like a memory leak or there is something else that fails to happen. At that point, those users who are only exposed to the high level abstractions, unless you provide a development environment that exposes memory leaks in terms of those high level abstractions, how do you How do you deal with that problem?
No, I mean that's a very real problem as of today, because in a sense you are elevating the application development to higher level of abstraction, but these are not executable in some sense. They need to be translated to some executable platforms like programming languages, and the debugging would happen at this level only.
See, whether it's debugging or testing or deployment or any of those things, they happen at a lower level. And so my real question is, how much of the development time or how much of the total life cycle is actually spent in writing the code? And how much are you really saving by doing this? Since eventually you have to expose the rest of the stuff anyway for people to get this thing to work. That's the real question.
Sure. The problem that one has to debug at this level and not at this level is there. You can't get away from that. But if you didn't have this level of abstraction at all, then it has two disadvantages. A, I have to write everything at a code level, and especially when you are talking of 5, 6, 7 lines of millions of lines of code, just that sheer size becomes a problem in itself when you are operating at this level. A higher level of abstraction seems merited. Now, if you are not introducing redundancies when translating from these textual DSLs onto the programming languages, then it is possible to have traceability from your Q++ code to C#, Java, or C++ code, which is which is a debugging aid. I mean, it's not very good, but it's better than having nothing.
So maybe I can take a quick shot at that. In putting together something, factories draw from a lot of experience in doing similar things, and one of the things we found is that unless people have a way of debugging with an abstraction, they don't think in terms of the abstraction. To really live in an abstraction, you have to be able to step through it, debug it, measure it, instrument it, and so on. The second thing we found is that in practice, the number of different areas of concern that people have is usually much larger than 3. In other words, they need to be able to create their own areas of concern and define the abstractions appropriate for each area of concern. And one ends up with a significant number. So for a typical application, we would expect to see 30, 40 viewpoints. Now, when you have that level of granularity, the abstractions are much more focused, okay? And the developer is better able to predict meaning, better able to intuitively understand the semantics of the diagram or the language expression. The third thing that I would say that relates to Ashutosh's question is that we found that a lot of people aren't ready to model. In fact, the industry at large is very skeptical about modeling and wants to come bottom up. They're comfortable building patterns to capture some IP. And maybe they would build some templates and some wizards to instantiate those patterns. But that's a stretch for a lot of folks in the patterns community. To go all the way to having a modeling language is a huge leap. So one of the things that we've been focusing on is identifying those areas of concern, viewpoints, and then enabling people to build bottom up. So they can provide some guidance that doesn't go all the way to the level of providing a black box abstraction. White box abstraction, like some patterns, maybe some help text or other forms of guidance, maybe a class library. And at the end of the day, if you can wrap a class library or framework in the language so that the gap between the language and the framework is really small, a lot of the concerns of confusion about what's being generated go away. In particular, if the amount of generated code is very small, that problem becomes much more tractable.
Yes.
Final comment on this kind of starting point of this discussion, which is that the debugging, deployment, many testing, a lot of other activities would happen at the lower level. In many ways, this picture is very similar to going from coding an assembly language to coding in a high-level language such as C. You're just raising the level up, and all that's missing is a set of tools at the level, at the bright blue level up there. And the question, is there anything that would prevent you from building those tools, should you choose to do so?
In terms of these two boxes,
exactly,
it's not a big deal. Those things can be built very easily.
But in terms of those boxes and abstractions at that level, never reaching down for debugging it.
So I mean, a very good example of that is the SAP ABAP programming language. They've actually built. They don't translate from that into a bunch of other stuff. I mean, you actually program, you debug, you do everything in it. That's what Prashant is referring to, which is, can you raise the level of tools up to that level of abstraction?
I mean, again, what I would like to answer is, when it comes to such, in these two specific cases of Q++ and SQL, building debuggers and appropriate programmer productivity tools is not an impossibility. It is possible. It's the question is in terms of models. If you have different kinds of models, different kinds of meta models, and those meta models are truly abstractions. And from that abstractions, you are generating a lot of code. So there is a fair amount of gap.
I'm sorry, how is that different from the abstraction of an object in C++, which is an abstraction? I mean, without splitting a hair, it's all abstractions.
Yeah, it's not an impossibility. It's just that they have to print, because whatever is there in the abstraction is anyway interpreted by the code generator. So code generator has the semantics for it.
So the other thing we found is that sometimes generating the code is a little bit too much for people, especially early on, especially if you don't have the complete tool set that helps people live inside the abstraction. And so one thing that's very useful is to validate. One way of thinking of this is saying that, well, architectural decisions are really very coarse-grained design decisions. They're not all the design decisions, and architecture is an incomplete specification. It's intended to provide the guidelines of the structure within which much more fine-grained design decisions are made and implemented. And sometimes when you work at that finer level, you find that some of the higher level decisions are wrong, and you have to go back and revisit them, right? So validation and constraint is a very powerful technique that can be used with models that doesn't require full generation of implementation.
Yeah, that's true. Yes.
How many more slides do you have? I mean, this discussion is very interesting, but I came here to hear about your system, and I hope we'll have time to do that.
I mean, I wanted to just suggest that as well. I mean, it's great that we're having this discussion, but in some sense, actually, I think we do want to hear what those guys have done. Right? So please let them finish, and then let's continue this.
Okay, so the toolset essentially supports repository-centric development, and it provides a component modeling framework, an IDE, support for model-based generation, higher-level languages, etc. I think I will go to the meat of it. Okay, so essentially, our toolsets are, on the left-hand side are the input specifications, the Q++ code, design strategies, extended UML models, and the query code. And then for every specific platform that you want to generate into, you have appropriate code generator as seen over there. Now, as you can see, the design strategies seem to have an impact on many of these boxes. So this is just a representative usage data of some of the applications which were built using this approach.
Actually, I think we should go back to the previous slide, because that was the reason why I invited these people. Because I saw that when I was actually, my jaw just dropped. And you should just explain those numbers one more time.
Fine. So the first row, it's a state-through processing system for our Swiss client. The number of classes were about 334. The size, and these classes essentially and the specifications comprised of business logic, business rules, and queries, and the generated code was about 3,271 KLOC, close to 3 million lines of code. And we generated the complete application layer, the complete database layer, and the entire architectural glue of how these things fitted together. And it was deployed on IBM mainframe, being the host end server, Sun Solaris being the middle tier server, Windows NT being the application clients. The programming language was C++, both on the Solaris and mainframe. Java, we used the GUI was in terms of swing controls in Java. NQ series was used as the messaging middleware connecting Solaris box and the mainframe. WebSphere was the web server connecting the clients to the Solaris box, and this entire architectural glue from clients, middle tier, and the host end was specified as attributes to these special meta models and code generated therefrom.
How big is the meta model? You're generating a lot of different stuff there. How big is your built-in meta model to be able to generate all that stuff? You're generating queues, you're generating all kinds of middleware plumbing, database. I mean, you gave us a few high-level classes up there. That's very nice to get a feel, but I mean, what does this environment actually have in it? Must be huge.
Actually, each of these systems has its own specific meta model. And a meta model is defined in terms of a generic meta model, and the generic meta model is very simplistic. It actually has meta object, which has meta properties and meta association. That's it. This is the generic meta model. Generic meta model, in terms of which any specific meta model can be defined.
But when you get down, you're generating Oracle or DB2, you're generating MQ, perhaps other queuing systems. I mean, you must have generic meta models for that. You're not generating a brand new meta model for queuing for every one of these products, are you?
No.
So there's something in between that meta model and the technology specific stuff, and I'm trying to get a feel for just how big that thing is and how much work is it to put it together. I mean, it must have taken you years to come up with something that's complete enough to generate the whole application.
Actually, size may not be a good metric for a meta model, because it would just mean how many meta objects you have, how many meta properties you are having, and what are the various kinds of associations that you have. And it's not very big in that sense. I mean, for example, a meta model for this application would typically have maybe 20 or so meta objects, probably 50 or so associations, and maybe hundreds of meta properties all put together. That's all. It is the interpretation